Welcome to the ORP for Pool and Spa Sanitation presentation. My name is Rick English, and I'm your teacher, and I'll tell you a little about myself. So I made this video to try to give you the information that I had gathered in putting together this presentation. Um, a lot of you already know me. My name is Rick English. My company is English Pool Consulting, and I started building pools in 1977 and started the consulting business in 1998. I have a bachelor's and master's degree in engineering from the University of Arizona for the master's and Rutgers for the undergraduate. Um, I've been doing a lot in the pool industry. I have 2 contractor's licenses. I hold a CPO, and I'm also a CPO instructor. I hold a certified building professional, um, and I've actually been teaching the course, the pool and spa construction course, for quite a few years. That's been changing a lot since PHTA became the uh, the organization. Um, and in a month or so, I will be taking the test for the Master CBP. Um, as an expert witness, I've been hired in a bunch of different states, as far as the Virgin Islands, Hawaii, quite a few, of course, in California, and a lot in Nevada, places like that. I just got a new case in Colorado. So I've been around, I've seen a lot, um, and I look at a lot of pools. I don't endorse any products. I don't endorse any pool builders, any pool service people. Well, that's not true. I do endorse some pool service people, um, but I'm very selective about that. My biggest concern is I don't want to get complaints from people that I make referrals to. So if I refer you and I get a complaint, even if the customer is unreasonable, I um, try to dissolve our relationship. So we're going to talk about pool and spa sanitation before we can talk about ORP. And I know a lot of you already know this, so you wouldn't be taking this course if you didn't already know this, but I think we have to put this in perspective. So what we're going to try to do today is talk about the differences between disinfection or sanitization and oxidation, and a little bit about the chemistry of chlorination, the impact of pH, very important topic, and explain how factors can affect the fluctuations of pH during the course of the day. Understand the role of ORP in all of this. Sanitation is keeping the water clean, preventing outbreaks. Um, I always like to say sanitation is killing all the bad guys in the pool. Um, in order to do that, we have to maintain proper water balance, and we all know how to do that with our Taylor test kits or some other type of test kit, even electronic type of test kit. We all know how to get that water balance when we're on the job. Proper circulation is key, and proper filtration is also key. So the most common form of sanitizers are chlorine and bromine based, and you can see this is what they call the periodic table of elements for those of you that forgot your high school chemistry, that this column here are what we call halides, and chlorine is number 2 on the list, bromine is number 3 on that list, iodine is number 4 on that list. This is fluorine up here, number 9. We don't use that because it's primarily a gas, but of course so is chlorine. And I forget what these last 2 guys are. My chemistry is a little bit rusty as well. So some of the factors that lead to inadequate disinfection. Now, we use the word disinfection and sanitization pretty much interchangeably throughout this discussion and pretty much interchangeably throughout the pool and spa industry. So, poor filtration, it's a big factor. Water balance, already mentioned that. Extreme bather loads. The quote code is 1 bather for every 20 square foot. And we can see some pools get really full of people. I remember when I used to have scout meetings at my pool, we had a lot of kids in that pool. And they weren't all the cleanest. Presence of fecal matter. When I teach the CBO class, I like to say toilet paper is a great product, but it's not perfect. It doesn't get it all, which is why we encourage people to take showers before they get in the water. And of course, showers aren't perfect either. Sunlight can screw up water balance. Wind and rain can screw up water balance. So, disinfection or sanitization versus oxidation. Disinfection destroys organisms, kills the bad guys in the pool and spa water. Oxidation, changing the chemical structure of contaminants in the pool and spa water. All right, what the heck does that mean? I like to say that sanitization or disinfection is killing the bad guys. Oxidation is burning up the dead bodies. A little bit of a gross analogy there, but it tells the story. So, which of these is more important? Well, they're both important. But if you had to choose one, in my humble opinion, and I know a lot of people watching this are going to say, this guy's really full of it at this point. Oxidation. Oxidation will destroy organisms if you give it enough time. Example that I used before, if we throw a wet log in the fireplace. Now, when you put a log in the fireplace, you're oxidizing that load. You're converting it by a process called oxidation, and one of the byproducts is heat, and flame. This is why we put logs in the fireplace. Well, some logs aren't ready to go in the fireplace because they're wet, but if you throw a wet log in the fireplace and you keep that fire going, sooner or later that wet log is going to get oxidized. So sooner or later everything gets oxidized in a oxidation environment. And we'll talk a little bit about ozone going on here. So the most common pool and spa sanitizers are chlorine and bromine. They're strong bacteria. There are separate bactericides and algicides that you can buy to boost those. But the important thing about chlorine and bromine is that you can maintain a residual so that when everything shuts down, there's still sanitizing going on in the pool. There's a level left in the pool called residual of free available chlorine. Whereas if you use oxidizing like ozone and some other products, once the ozone hits the water, it's gone. It's gone. It has a very short half-life. You turn that equipment off, it's gone. So it's great, but it doesn't leave a residual, which is why we have to have, if we're using ozone as our primary sanitizer, we still have to have a chlorine residual, at least in the California Health Code. Can be used as sanitizer, chlorine, that's free available chlorine, sanitizer, algicide, shock treatment. So chlorine-based sanitizing agents, solid forms that have a good shelf life, and all of these things have pluses and minuses. We know the solid forms have cyanuric acid attached to them, and they can add sometimes too much cyanuric acid to the pool. Solid forms can damage if you throw tablets in a vinyl pool. uh, you're going to have problems. If you throw tablets in any pool, you're going to have problems. But vinyl and fiberglass do not like tablets at all, at least in the pool. They don't mind them if you have them in a tablet feeder back in the equipment area. And I never recommend putting tablets in a skimmer. Um, they tend to decompose through exposure to sunlight, heat, and metals. So those are the um, solid forms of chlorine. Other forms of chlorine, you can get chlorine gas. Back in the 80s, there was a company going around that they go to your pool once a week and pump a bunch of chlorine gas into the pool. But again, it didn't last very long. So, and they only wanted to come once a week. If they came 2 or 3 times a week, you had a really good job of sanitizing your pool. But they couldn't afford to come once a week, so they went out of business. Um, they were doing my pool for a while back in the early 80s. Um, we get it, the most common that we see is that chlorine comes in a liquid form. It can also come in a powder form. The dichlor or calpipo, that sort of thing, tablets, and it can be compounded with a stabilizer, which is D-cyanuric acid, as I mentioned earlier. So what happens when chlorine gets in the water? It forms two products. It forms hypochlorous acid and a hypochlorite ion. And this is really the key that I've been leading up to in this discussion of pool chemistry. Free available chlorine is what we want in the pool, and that is the combination of those two. Once chlorine does its job, it forms byproducts. So it's formed when chlorine hits the water. So when you put chlorine in the water, you're going to get those two chemicals. Okay? The active sanitizer, the combination of hypochlorous acid and hypochlorite ions and chlorine associated with cyanuric acid. That's what we call free available chlorine. So it's both of those together, right? And that's important to know. Hypochlorous acid is 60 to 100 times more reactive than hypochlorite ion. Hypochlorous acid is the killing stuff. This is what really does the hard work, the heavy lifting in the pool. Hypochlorite ion, not so much. Now, so we would really like when we put the chlorine in water to get a lot of hypochlorous acid and not much hypochlorite ion. How do we control that? Well, we control it with pH. The percentage depends on the pH of the water. So, the lower the pH, the more hypochlorous acid. So, in other words, the more acidic the water is, the more hypochlorous acid. The higher the pH, the more hypochlorite ion. So, the more alkaline the water is, the more hypochlorite ion you're going to get. And we have this table that shows us how this works out. So you'll see, and you've been hearing, hopefully most of your life, that the ideal we like to keep pools at is at 7.5. At 7.5 pH, we get exactly 50%. And when I say exactly, it's not that precise, but it's close enough. We get half hypochlorite ion, half hypochlorous acid. We get that pH down around 7, we're getting 72.5% hypochlorous acid. So 6.5, we're getting 90% hypochlorous acid. And that's great, but the problem is we don't want people swimming in water that has a low pH like that. It's an acid. It's not really good for people. It's really not good at all for the plaster on the pool. So that's why we recommend keeping the pH above 7.2 and the ideal being 7.5. And that's how we control it. So free of available chlorine, we can test this with our test kit. And for pools, we want it 1 to 4 parts per million. Ideal, 2 to 4 parts per million of free chlorine. For spas, 2 to 5, and ideal 2 to 4. So these are the recommended ratings for free available chlorine. Now remember, I keep saying free available chlorine. Combined chlorine is what happens when the chlorine does its job. It combines with things like perspiration, urine, anything that contains nitrogen, and they forms these chemicals called chloramines. And there's more than one, but they're all not that very good. They just literally have almost no ability to, and when I say no, I mean very low ability to control, um, to perform sanitization or oxidation. Um, you will hear that some water districts actually add chloramines to the water because they want the very slow control of algae and bacteria. They don't want to keep it as instant. They want it very slow. So chloramines last a long time, but they don't really do diddly squat in the pool. And the other problem with chloramines is they stink, they're irritable. Uh, we don't, when we walk past a pool and say, oh, this pool smells like chloramine, we're really smelling those chloramines. They're nasty guys. So to form chloramines, combined chlorine, which causes unpleasant odor and eye irritation. Okay? So oxidation burns up the bad guys, burns up the dead bodies. Regular oxidation aids in better water quality. It can be done with chlorine. Chlorine is an amazing chemical because it does both sanitizing and oxidizing, whereas products like ozone only do oxidizing, and some of the mineral type sanitizers only do sanitizing. They don't do oxidizing. Chlorine does both. Chlorine is the king. Potassium monopersulfate is a non-chlorine oxidizer. Um, some spas you put potassium monopersulfate in their pools every day. Um, Good practice. Because the main thing potassium monopersulfate does is gets rid of the chloramines and the smell. Ozone is a very, very powerful, amazing oxidizer. Um, and hydrogen peroxide is another oxidizer. We can also make chlorine with chlorine generators by adding salt to the water, and this process is called electrolysis, and it will convert salt to liquid chlorine. Um, this is very similar to the process that manufacturers use to make the liquid chlorine that you buy. You can buy an inline salt generator, which is what we see right here, and it is, this is our inline generator. Um, this is the guy we see the most often. They're very popular. Um, and you can also see a brine tank. I was installing brine tanks at a product called Unichlor back in around 1992. And what a disaster that was. Now, I understand these things for public pools are a lot better than they used to be, and they're coming out with some brine systems for private pools as well. But make sure that you see that the product has a track record before you get into brine systems. And that's just a word because um, I was charging people an extra couple $1,000s for these brine systems. They hated them. I hated them. The company went out of business, and I ended up giving the customer the money back, plus take care of all the headaches. So anyway, so here's how salt generators work. They take NaCl, for those of you that remember your chemistry, that stands for sodium chloride, Na being sodium, Cl being chlorine. And we add 2 water molecules to salt, and that creates NaOH, sodium, and then this creates chlorine, Cl2 just releases the chlorine. It releases a hydrogen molecule which goes up into the atmosphere, and it's never going to come back. But we don't have to worry. There's no shortage of hydrogen. The universe is 95% hydrogen, so there's plenty of it out there. So salt and water forms two chemicals. Now, then the chlorine hits the water, just like we talked about a few minutes ago, and forms hypochlorous acid and hypochlorite ion. So all the salt system does is it introduces pretty much, it makes its own liquid chlorine and pours that into the pool. So then, so this is the chemical activity that takes place. But let's look at this a little bit. That one of the products that it performs is it creates is something called caustic soda. That's also called sodium hydroxide, and it has a pH of 14. So we're getting chlorine, but we're also getting sodium hydroxide. The salt system raises pH. The other problem with pH is what we call off-gassing of CO2. There's carbon dioxide in the water, and the carbon dioxide goes off into the atmosphere. Now, what happens when you add carbon dioxide to the water? You get something called carbolic acid. It's very unstable, but it's an acid. And the most common carbolic acid that you and I experience is soda water. So if you're drinking Diet Coke or Pepsi, any carbonated drink, they call it carbonated drink, that you're drinking carbolic acid. And as soon as you pop the top on the can or the bottle, we get a release of carbon dioxide. The carbon dioxide, carbolic acid is not terribly stable, but it does make a lot of bubbles, and that's what people like about it. So we have carbon dioxide in the pool water, and that of course wants to dissolve and go into the air, just like it does in your soda bottle. So the pH will rise until the CO2 reaches its equilibrium, or about 8.3. The more alkalinity, over 80 parts per million, the stronger the pull to a pH of 8.3. So that pH can really take off with off-gassing. This is one of the most difficult things for pool service techs to deal with, because as soon as you leave the job, it starts happening. And there are certain conditions that make it worse. Now, when water goes over a vanishing edge, it's exposed to the air. That carbon dioxide has got an easy way to get out of that pool water. So we're having a lot of off-gassing here. But that's not all. Look at the spillway from a spa. People run these all day long, and they like that look of the spillway. And, you know, who can blame them? It looks nice. But again, we're losing carbon dioxide, which means that the pH of the pool is going up. And so these are two sources, but then again, we've got things like slides and waterfalls that people run all day long, and those also cause the off-gassing of carbon dioxide. So how do we know when that pH, let's go back. Remember this? What happens when that pH gets up around 8, 7.8? The amount of hypochlorous acid in the pool goes way down. So how do we know what's happened once we do our test kit, brush the pool, and leave the job for the day? We can measure something called ORP, which stands for oxidation reduction potential. It's a measure of how much oxidation can happen in a pool, in water, whatever it's measuring, at any point in time. So think about that. Remember, we said chlorine does sanitizing and oxidizing, ozone does oxidizing. This measures whether or not the water has the ability to oxidize. So, some people would say that this is really a measure of essentially a substitute, maybe not perfect, but a substitute for measuring what that pool can do as far as sanitizing and oxidizing. They also call it redox. It's a measure of the solution's tendency to gaze or lose electrons, which I'm sure none of us care about, but really it's the water body's ability to cleanse itself or break down waste products. Well, hey, isn't that what chlorine is supposed to do? So it's measuring the effectiveness of the sanitizers in water. And this can be measured all day long, every day, and give us information about what's going on with this pool. So it's a very powerful thing, but how do we get the information? Excuse me. Got ahead a slide here. I'm not all that professional at making these videos, so you're going to catch my video ticks. So a higher ORP reading indicates that the pool is cleaner. A lower reading indicates that the water contains too many contaminants and not enough chlorine to sanitize the water. The optimal ORP value for the fastest and most effective killing is 750 to 770 millivolts. And you don't have to really remember what a millivolt is. You just need to remember this number here. So let's move on and take a little bit and look at pros and cons of using ORP. It may sound like, from what I just described, hey, this is the miracle that I've been looking for. I can tell if my pools are uh, are are no longer able to sanitize the water because the pH has rocketed up, which it really tends to do with saltwater systems and vanishing edges and all the other things that we talked about. So, can ensure higher water quality using pH. It's accepted by health departments, but once again, the health department still insists that you maintain a chlorine residual um, because I'm talking about ozone now. It, the pools run efficiently when they're using ORP, and that doesn't mean that you should throw away your test kits, right? Um, if you start using ORP, you have equipment, and that equipment is requires maintenance. Uh, it has to be calibrated. You have to follow the manufacturer's instructions to calibrate the thing, or it's going to give you bad information. You have electrodes. Electrodes are running through water, and if it's running through low pH water, it's getting attacked by acid. If it's running through high pH water, it's probably getting scale. So electrodes need to be cleaned and replaced on a regular basis. So here we see a brand new electrode, the end of it, and here we see one that's degraded, right? It's unreliable at certain times. If the water is really dirty, its ORP doesn't give you as accurate measure of, say, ozone and that sort of thing. Um, they're susceptible to outside effects. Sensors don't measure anything specific. Now here's the thing is they're not measuring chlorine. The ORP isn't measuring chlorine, bromine, potassium, anything like that. It's measuring the tendency, the ability of the water to sanitize. It's not measuring any particular chemical. So once again, dirty wash. Got that one in there twice. Some of the outside effects, sunlight, and other things will affect the ORP. Here is an simple ORP testing device that you could buy, just measuring the voltage in the water. Yes, there's voltage in pool water. Now, so the other thing that can happen is we get stray voltage in the pool. Now, ORP is a measure of voltage. It's that simple. It's a measure of voltage. So stray voltage can get in the pool and screw up your ORP readings. So, here are the different sources of stray electricity, and this slide isn't as good as I thought it was going to be. Damaged or melted neutral or ground wires can give you a problem. There we go. Defective lighting systems in the pool, damaged or exposed buried electric cables, faulty drops from overhead power cables. I point this out a lot of time. I was just looking at a pool in El Centro, and this property was kind of rural, but it had two power poles, one at each more or less property line, and it was a big property. They had a power pole at each property line. Each of those power poles has a grounding rod that goes down the side of the power pole. And what is that grounding rod for? Well, when you turn on or turn off an appliance, the electric company can't detect that, and it can't send more electricity or less electricity. So what happens when there's a whole bunch of electricity going down the wire and somebody turns off their air conditioner or their pool pump? Well, that some of that electricity hits that grounding wire and goes down into the ground, into planet Earth. Now, the Earth is not a good conductor, but I said it's not a good conductor. I didn't say it's an insulator. The Earth does not insulate. The Earth can conduct electricity. Not very well. We walk around in it all the time without getting shocked, but it can conduct electricity. And so that's how electricity gets into the ground, and that's one of the ways it can get into the pool, and that really gets around to the overall importance, critical importance of electrical bonding. You can also have problems with the electric panel. You can have damaged pads underneath transformers, a variety of other sources. So the trick here is to have a really good electrical bonding system. And today we even have to bond the decks around the pool. It wouldn't surprise me if we ended up bonding the coping as well. So here's how ORP is measured. The sensors consist of two electrodes, an ORP electrode, which is a metal electrode, platinum, sometimes gold. The typical accuracy is plus or minus 5 millivolts. A reference electrode, the same, what's called silver chloride electrode, used with pH measurements, okay? So, we have a potassium chloride solution, and we have liquid that's being measured, the blue stuff here, indicating electrode, platinum or gold, junction, reference electrode, and then we measure the delta E. Delta is a Greek letter that stands for change, and E stands for voltage. And every time I teach a class on electrical, they say, why do we use E for voltage instead of V? Because the real word is equipotential voltage, okay? So E is actually appropriate but confusing. You can buy some ORP measuring tools that you can carry with you, and if nothing else, it's going to give you a measurement. You can come back as many times as you want and read them. So these are portable. You can buy them for a couple $100. I think they get up as high as $1,000, and they're as low as maybe $150. So here's one. Portable meters with no frills. This is by a company called Milwaukee, manufactured to be easy to use. They perform ORP measurements with a range of plus or minus 1,000 millivolts. Now remember what we said the effective range was. So, and it comes with your electrodes and all that sort of thing. So I'm just giving you a sampling of some of these different ORP meters you can look at. Here's another one that you can look at. This one to me looks a little bit easier to use, but it actually stores 50 sets of measurements, and it has a nice display. I'm not sure who makes this one. YSI Pro. So if you're watching this, you may want to do a screenshot and save some of these pictures. There's plenty of these. It's not too hard to find them. Here's one called X-Stix ORP meter. And again, it shows a bar graph showing change in ORP reading. It has a memory. A lot of these can store measurements, and so that's nice to have. Here's a little bit bigger one, and this is called by a company called Oakton, and I think this is a little bit more expensive. There are two series. They save up to 1,000 data points. Right? But the real key, and the whole reason that we're talking about ORP today is that there are a lot of salt generators out there, and some people hate them. I think they're quite a wonderful product. They really help in controlling chloramines too, but that's another thing. But they do raise the pH as soon as you turn them on. That caustic soda starts going into the pool and starts raising the pH. And so we're getting lots of chlorine in the pool, but we're getting less hypochlorous acid and more hypochlorite ion as the day goes on. And that makes for a less effective killing system in the pool. Ultimately, we are talking about chemical automation. More and more pools are automating their chemistry. And the only way you can automate chemistry, because you can't measure chlorine, free chlorine, hypochlorous acid electronically. But what you can measure is ORP, which tells you whether that pool is doing its job, ready to do its job of killing the bad guys and getting rid of the dead bodies. So it has a lot of advantages. Now, we all have seen them in commercial pools, public pools, but we're starting to see more of them in residential pools. And that's what I want to talk about for the rest of this discussion, that this is something you want to consider. This is something you want to talk to your customers about. And this is something you want to get knowledgeable about. And you're not going to get all that from this talk today. Okay. Water balance. Okay. Because the chemical automation systems can measure pH as well as ORP, and they can adjust the acid levels. Okay. Remote control. A lot of these things are what we call smart systems. They can tie into your customer's Wi-Fi. They can send text messages to your office. They can send text messages to your phone. They can let you know if something is really going on, and they allow you, using an app or using a program on your computer, to make adjustments. So they're going to save energy. You're going to use less chemicals. I mean, that's a selling point. I can't really say that I have experienced those two things happening, but it makes sense that they would. Um, but you're monitoring things constantly. And as we said, if you look at all the things that can go wrong with the pH of a pool once you leave that job, it's amazing that we don't have more problems than we do. We can program pumps, we can all these things um, with the chemical automation, and again, big selling point. So here is a simple chemical automation system from a company called RollerChem. Monitors pH, balance. Now, these chemical systems, there's also going to be a acid. Um, there's going to be a barrel of acid that the system can use to dispense extra acid to the pool to control pH. Controls one sanitizer source. Usually, this is going to be your chlorine, your salt system, uh, and monitors pH and ORP. Redox, which again, that's ORP. Dip switches, you don't care about that. Built in when everything goes out of range, it lets you know. So that's a real simple, relatively inexpensive system that you could be looking at. Now, Pentair IntelliChem has become a pretty hot item, especially in Southern California, where Pentair is very popular. Um, and this system monitors pH, sanitizing levels, ORP. It calculates the Langler saturation index, which those of you that have taken your CPO course know what a Langler saturation index is. I'm not going to explain it here, but the Langler saturation index is to control the ability of the water to screw up the plaster. And I mean, that's an exaggeration, but it tells whether the water is um, aggressive, which means it can attack things like plaster, or whether it's scaling, which means it's going to leave white discoloration on the plaster. So, um, and it's an important thing to monitor. Um, it's again, it's not really a critical thing for sanitizing, but it's very important for water balance. And so here we have the Pentair IntelliChem. And again, this looks pretty simple, but when again, it has to attach to electrodes and sensors that are going to measure the water. It has to connect to a device that will, again, a bucket of acid so that it can balance the water in the pool. Um, it dispenses muriatic acid or CO2. A lot of you don't realize that you can have CO2 feeders for pools. Again, we don't see them that often because you have to buy CO2 in containers and then replace them every once in a while. Um, uh, they use a flow cell for a pH dispenser to detect the proper pH level. They keeping chemicals away from the pump in case the pump shuts off. Supports Pentair automation, and as most of you know, there's the Easy Touch, the IntelliTouch, the Screen Logic, and all that sort of thing. And of course, it talks to the Pentair's salt generator. Um, so again, I'm not endorsing any product here. Hayward has one called Sense and Dispense. It's a two-part kit, and part one senses pH, chlorine levels. It dispenses chlorine generated from salt. Okay. A manifold connects to a CO2 tank or carbonic acids, feeding the tank to dispense pH. and compatible with the Hayward OmniLogic automation system. So um, pretty much similar to the Pentair system for those of you that are Hayward people, and not as popular in um, Southern California, but very popular nationally. In lots of parts of the country that I travel to, you don't see any Pentair, you see all Hayward. It's funny how brands um, tend to be popular on a local level. So one part of the country or one city will be everybody uses one brand, and another city they all use another brand. We have a lot of great products out there, and they're not all made by one manufacturer. So here is the Hayward system with the OmniLogic. Here is their controllers, and of course there's their salt system. Jandy has something called TrueDose, and it detects pH and ORP, and it ties in with the Jandy AquaPure salt system, and it has a peristaltic pump. All of these have a peristaltic pump or a diaphragm pump for pumping liquid acid into the pool. Does enough acid for most residential pools, and connection with TrueDose chemical fittings and tap included. So again, this is another one-stop solution for those of you that use Jandy equipment, because it's going to tie in with the AquaLink, the iAquaLink, um, that sort of thing. And here's a picture of what the Jandy TrueDose looks like. The Attendant is the latest to come along, because it is the one that says, hey, we can talk to any type of controller. We can control any brand of variable speed pump, not just turn them on or off, but any brand, compatible with the big three and some others. It also is compatible with, you can buy it with Attendant Plus Chemistry. Look at the Plus Chemistry up there. You don't just buy the Attendant, you buy the Attendant Plus Chemistry, and it comes with the pH and ORP sensors built in, so you can tie that into any control system. This product is pretty exciting. It's also pretty darn expensive by the time you get it in there, but it's nice to see. It's very frustrating that you can't control a Hayward pump with a Pentair controller. All you can do, you can turn it on and off, but you can't set the speeds. And the Attendant says that they can do this. Plus, it stores everything on the cloud. But I believe that Jandy stores everything on the cloud as well. So, summary. Here we have our chemical automation system, all right? And here we have our standard pump, filter, and heater. And we can summarize with a few points here. This is the last slide. Even with a balanced pool, pH can be very unstable. High pH means less hypochlorous acid. Monitoring ORP is another tool with great potential and some limitations. Affordable chemical automation is now available for residential pools. So that is my ORP presentation that you were supposed to get on Friday morning. I was hoping to have a lot of professionals in here who could add to my comments. So I miss that. I miss having your comments. I miss having your criticisms. I miss having your pointing out the errors in my presentation. So you know how to get a hold of me. My email is rick@english.net. I don't think I have a slide on that because I wasn't anticipating. I was going to give everybody a business card, but things changed. But this video, I hope, is a substitute for my mistake in scheduling the appointment to speak to you guys on Friday morning. And so I'm going to make this available either on YouTube or on my website, and I will get a link to you.